Alright, in this lesson we're going to talk about trig proofs. Okay, trig proofs work similar to the way that proofs did in geometry, where we start off with a given piece of information and we want to prove something. In trig, what we're normally given is some sort of identity, so an equation that two expressions are equal, and we want to show that they are in fact equal by a series of logical steps that you can deduce from step to step until you get to what you're asked to prove. Okay, so we're going to start off with the algebraic proof to kind of see the form of what our trig proofs are going to look like. So example 1, we're asked to prove the algebraic identity x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1 equals 2. Okay, so for our trig proofs, our first step, we want to start with one side of the equation, and typically we'll start with the more complicated side. So the side that has more stuff, because it's generally easier to go from more complicated to simpler than it is to go from simpler to more complicated. So let's start with this left side. It definitely looks more complicated. So I'm going to take this side here, and I want to keep my goal in mind. I want to, through a series of steps, I want to rewrite this form of this expression so that it becomes 2. So let's start here. So the first thing I see is I've got a couple of difference of squares in the numerator. So I want to go ahead and expand those to x plus 1 times x minus 1. Okay, so both of my x squared minus 1s I just expanded to their factor form. So now we can see that we've got common factors on the top and the bottom of, in our first term, x minus 1. So anything over itself is 1. And in our second term, we've also got, nope, that should be a plus, shouldn't it? All right, so let's keep that one, and let's cross through that one. Okay, so we've got x plus 1 crossed out. And what are we left with? We've got x plus 1. From here, take away x minus 1. No more fractions. Okay, and again, we want this to look like this. So, we're subtracting, and then we've got to be careful here, Mr. Flory, that we're subtracting all of x minus 1. So if we want to distribute that subtraction, then we've got x plus 1. We bring it down. We're going to subtract x, and we're going to subtract a negative 1, which is the same thing as adding a positive. So now, if we combine our like terms, we've got x minus x, and we've got 1 plus 1. Okay, anything minus itself is 0, so we've got 0 plus 2, which is just 2, so we can bring down the right side of our equation. 2 definitely equals 2. So we knew we were finished when we simplified one side of our equation to make it look like the other side. Alright, so now let's look at a similar identity but with trigonometry inside. Alright, example 2. Prove that tangent of x plus cotangent of x equals secant of x cosecant of x. Alright, so step 1, we want to pick which side we're going to manipulate. I'm going to go with this side. We've got a sum, and this side just, I don't know, neither of them look simple, but I'm going to start with this side. Alright, so from our quotient identities, and those identities, this is so important where they're going to come in handy to where you can just kind of spit them out like you would a multiplication table problem. So tangent of x. Sine over cosine. Cotangent of x is cosine over sine. Okay, and again, we're just looking at one side of our equation. It's a whole lot like what we did when we first learned our identities, where we were just simplifying an expression using our identities. The difference here, and it's kind of a bonus, in that we know what our goal is. We know what it's going to look like when we're done. Okay, when we were just simplifying them in 5.1, or 6a, 9a, we didn't exactly know what we were going to get when we were simplified. Okay, sometimes it would be just a trig function, sometimes it would be a constant, we didn't know. But now we know. All right, so now, this is just one term here, but over here we've got two terms. Typically we'll want to combine that into a single term. So when we've got fractions, we need a common denominator. So I want to combine these into one term. So I want to get a common denominator. This guy I'm going to have to multiply by sine of x on the bottom to get my common denominator. This guy I'm going to have to multiply by cosine of x. Okay, we do it on the top and the bottom so we don't change the value, just the form. Okay, we've got a 1 here, a 1 here. So now we've got sine squared of x over sine of x cosine of x plus cosine squared of x over sine of x cosine of x. See where this one's going? Okay, so now we've got common denominators, combine them. Okay, and again, our goal is to make it look like this. We've got one term now, which is good, so we're slowly making our way towards that. Now, we know from our Pythagorean identity that sine squared of x plus cosine squared of x is just 1. So let's rewrite that. So we've got 1 over sine of x cosine of x. Okay, we're almost there. So I'm going to split this into a product, since this is a product of two trig functions. I'm going to split this into 1 over sine of x and 1 over cosine of x. Okay, and then from our reciprocal identities, we know 1 over sine of x is our cosecant x, and 1 over cosine of x is secant of x. And we can switch the order of multiplication anytime we want to. So this is secant of x, cosecant of x, which is exactly what we were asked to prove. So, example 2, check.